Hey everybody, welcome to our Chapter 4 review. We'll get started with page 1. For these first couple of problems, this goes back to when we were talking about proving lines parallel. So what you want to first notice is this is what we're trying to do here, prove objects parallel. Notice we're given a couple of angles. So if we're trying to prove parallel, this is the case where we would have to use the converse of those ideas we talked about, because those ideas started with the effect that two lines were first parallel. So here, notice in the positions these two are located, this is, of course, alternate interior angles. That's where they are. But again, as we just mentioned, this has to be the converse of the AIA theorem. And that theorem did say, if lines are parallel, then these two angles will be congruent. The converse, which is in play here, is if two alternate interior angles happen to be equal, then we can conclude the lines are parallel. So these, like before, the key word we want is converse. Same thing happens here. This will be the converse of, in number 2, the same side interior angles theorem. And that theorem said angles in those positions must be supplementary or total 180. That's exactly what's going on here. So for number 2, it's the converse of the same side interior. Continuing from this point for number 3, something that may help you is, if we're trying to prove the lines equal, let's draw those in a little more extended to the left and to the right of our figure. These are the two we want to try to show as parallel. Maybe once we draw those in and think about our idea of a transversal line coming through and intercepting, let's say at points N and I, this will be our transversal line. When that happens, notice the angle marks that you have are in those two positions. Again, those are just like number 2, same side interiors. So if we want to justify this, we want to use the same side interior theorem. But again, we're not starting with parallel, we're proving parallel. So this, of course, then has to be the converse of the same side interior angles theorem. And that was our shortcut there. Similar ideas continue in questions 4 and 5. For question 4, notice the positions these are in. These are alternate interior angles by name. So in order for the lines to be parallel, those two angles would have to be congruent. So let's force them to be congruent and then solve for x. And now this should be very familiar territory to most of us. We subtract 18 from both sides. 2x equals, let's see if we can do this in our head here, 106. So x must have a value of, when we divide by 2, looks like 53 is a nice final answer here for x. For number 5, we have something similar, but notice the positions here. These angles are same side, and they are outside or exterior to our set of parallel lines. And just looking at what we have, one is acute, the 44-degree angle at the bottom. One is obtuse. There's no way in the world those two angles ever could be equal to each other. So you might even be able to convince yourself that this has to be 44 degrees plus the 3y minus 2 degrees must equal 180. As a matter of fact, same side exterior angles are supplementary to one another. Let's combine like terms here, and we will get plus 42. Notice again the 2 and the 44 are your bare numbers, and that's still equal to 180. And then our usual solving steps. Subtract 42, we should get a 138, and then when we divide by 3, we will end up getting, it looks like it may be a 46. You could double check that on a calculator. Looks like we have one problem left on this page, number 6. And it might help if we see this a little bit larger. So let's blow this up a tad and see what we have. A couple things to notice right off the bat. Two lines here are parallel, which means then between these two lines, might help if we draw those in, huh? Between these two lines and any transversals, I see 2 transversals here, we've got some congruent angles. So I notice A here and 78 are same side interior. So there we want to make those supplementary, don't we? So it's going to be 180 equals 78 plus A. And just doing a quick little mental math here, it looks like A must be 102 degrees. Likewise, if we compare the 78 we have to B, we would call those corresponding angles. And we said anytime there's parallels with a transversal slicing through, those must be congruent. Simple answer for B is simply 78 degrees. You could have also used the fact that A and B together form a linear pair, and therefore those two must be supplementary. Okay, continuing. Noticing across the way letters C and D are a linear pair, these two guys right here. And those are also related somehow to angles going on up top here, right? It looks like angle D and these two angles taken together, the 44 plus the unknown angle, try to draw a question mark in there, must be equal to each other. Those are the two obtuse angles here, we would say are in corresponding angle position. Problem is, we've only got 44, but if you notice right across the way, our 78 degree angle is a vertical angle with the one that we have given here and here. I'll shade those corners for you so you can see. So it looks like this obtuse angle now, 78 plus 144, it looks like that will give us 122 degrees. And you might want to double check that we add those two together correctly. That matches with letter D, so it looks like letter D would also be 122 degrees. Then by default, of course, letter C would be the linear pair supplement to that. We would get C by writing 180 minus 122 and carrying out that subtraction. Looks to me like a 58 degree angle. And then we can write our answer D here at 122 degrees. Okay, so let's maybe see if I can do some erasing here. So here we go. Let's try to erase some of the stuff here that might be interfering a little bit. Come on, little eraser. You don't want to work, do you? Okay, let's just go to a different color here. For the rest, notice that we already have angle C down below here. And if you follow along the red parallels to see the other matching angle, letter F, follow along that transversal, notice C and F are corresponding angles, which means C and F must be equal to each other. So let's put F at 58 degrees to match the previous answer. Let's focus our attention now near the square corner down here. And notice that square cornered angle plus angle E plus the 64 makes a straight line. All three angles taken together would be supplementary. So that would mean to figure out the measure of angle E, I should make 180 equal to 64 plus the 90 degree angle plus letter E, the one I'm trying to find. When we combine 90 and 64, we get 154, and then subtracting 154 from both sides should get us our angle degree answer for letter E. It looks like 26 degrees is the answer for E, so let's fill that guy in too. That brings us to the end of this page.